afternoon, Nana, everyone. Is my voice audible? Oh, sure. Lakshmi Sapika. So it is audible today. So no problem, no issues are there. Right. Okay, Nana, we will start the class. But attendance is very poor today here in the Zoom app. Maybe many are watching in YouTube. Okay, right. Exactly where we stop on one problem. Question I got -1 Shrestha. I think it is not correct, Nana. Okay. Right. So yesterday I gave, I think there is a bomb on the surface. If I take the surface like this, three-dimensional, and here there is a bomb. Uh, Suppose this is the bomb what I placed here, and it will split into two parts here. I think three parts, like one part will two equal parts. Total mass, how much now yesterday I gave? Anyone remember the problem? 12 kg, right, right. Ratio, 1 is to 1 is to 2. Very good, very good. So given that the solution for the yesterday's problem, 1 is to 1 is to, okay, right. A ratio of, I think someone is asking Zoom link there. Who is this new fellow? It is complete Urdu. I can't understand him much. Some Urdu person is asking the Zoom link in WhatsApp. If possible, anyone try to send the Zoom link, Nana, for that person. Okay. Then here, if you see the two parts, ratio is equals to, yeah, Lakshmi Gayatri, you got -2, Nana. Maybe correct, Nana. If you send the Zoom link in your group, Nana, anyone of your class? Right, good. Kalyani, thank you. All right, ratio is given as 1 is to 1 is to 2 at Nana. Given that, what you say, and equal masses fly at mutually perpendicular directions with what velocity, Nana? Velocity given? No problem, Isha. Oh, this is iPhone. Okay, right. 2 meters per second. Okay, right. So here these two masses travel with 2 meter per second and 2 meter per second. Total mass is equals to 12 kg, that implies the ratio will be 12 by 3. So 3 is to 3 is to 6. So the equal masses are 3 kg and 3 kg here. Okay, good afternoon. This is also of 3 kg. Okay. And the third mass travels with what velocity, he asked Nana. Now you can understand what is the use of the vectors concept here. Okay. Observe, initially the bomb which is placed on the floor is at rest or in motion, Nana? Like yesterday's concept, before and after. Yes, it is at rest. Before the instant, after the instant. That instant is explosion. Again, this bomb explodes into three pieces. Okay, so here before the explosion, bomb mass is 12 kg. So velocity is equals to 0. So P1, linear momentum before explosion, is 12 mass into velocity, that is equals to 0. This is before the explosion. After we found three masses, first mass is equals to second mass. Uh, Assignment problem. I did not. Nana. M1 is equals to M2 is equals to 3 kg and M3 is equals to 6 kg. Okay. Now, total linear momentum of three pieces P2 equals to, now look at what I am going to write here. The linear momentum of first 3 into 2, 6. Better I write it as 3 into 2 so that you can understand. 3 into 2. Is it along x-axis or y-axis? X-axis. I don't think it's on Mr. iPhone. Means in vector form, can I write it as I cap, Nana? Okay. Yes, yes. And the second part is moving along y-axis. So its linear momentum is 3 into 2. That is also 6. That is moving along y-axis. So I am going to write here j cap. This is of second piece. First piece, second piece, including the direction. Okay. Plus third piece is also there. Third piece, I know only the mass. I don't know the velocity. Not z-axis, man. I don't know. Okay. I can't predict whether it is along z-axis or some other direction. I don't know. So here the third, yes, bigger one only, Nana, what I'm saying. You observe here, you will get the clarity. Okay. Uh, Not K cap, Nana, that's what I'm saying, Ishan. Okay, why are you in hurry and doing the mistakes here? The third piece, mass I know 6, into velocity I don't know, so let it be V3 bar. Its direction is also I don't know. That's what I'm saying. I don't know its magnitude. I don't know its direction. The question itself is find out the magnitude and direction of the velocity of third piece. Okay. So understood this part, Nana? That's why here I can't write whether it is I cap or J cap or K cap. I don't know. That's why simply leaving it like V3 bar. Yes, yes. Assuming it as V3 vector form V3 bar. Okay. And finally, you know both the moment are equal before and after. Okay. So before means according to as usual LCLM, law of conservation. Yes, that's what I'm doing. Law of conservation of linear momentum according to that concept. before is 0 equals to after is, before is 0. After is 3 twos are 6 I cap plus 3 twos are 6 j cap plus 6 v3 bar. Okay. So I'm taking here, I want v3. So 6 v3 I'm leaving on the left hand side and bringing the remaining two known things to the other hand. That becomes here, observe Nana. Observe here, on the other hand, I'm taking this is minus 6 I cap minus 6 j cap. Okay. Now look at here, v3 bar is equals to, I am getting minus 6 I cap. What is LCLM of? For a waste fellow. iPhone, what is this? Okay. 6 ones are 6 ones are minus I cap and minus j cap after cancel. Okay. I don't explain. Okay. All right. This is V3 bar. Law of conservation of linear momentum, Nana. Law of conservation of momentum. Okay. Now exactly look this one. What I am saying. Minus I cap minus j cap means that is not along z axis, Nana. That is minus x coordinate minus y coordinate. Means if you take in the coordinate system, first quadrant, second quadrant, third quadrant, fourth quadrant. Assume it is in what in the yes, it is in third quadrant exactly. X component is negative, y component is negative. Third quadrant. That's why the third piece will travel into the third quadrant, not along z-axis. That's what I'm saying. Into the third quadrant here like this. Better I take another color. Third quadrant. Okay. This is the direction of velocity V3. That too it is V3 bar equals to minus I cap minus j cap means it is like AX I cap minus AY j cap. AX value is minus 1, AY value is minus 1. In vector notation, AX I cap plus AY j cap. So AX is minus 1, AY is minus 1. Yes, yes, yes. And then it makes some angle, suppose with x axis, alpha, tan alpha is equals to formula AY by AX. I think you remembered in your vectors chapter. AY by X means minus 1 by minus 1, that becomes 1. That implies I am getting here alpha is equals to 45 degrees. Okay, so direction is over. It is 45 degrees means with the third piece exactly moving along x-axis with the first piece, will you say what is the direction here, Nana? What is that angle? Will you say that angle? It is very easy. Yeah, exactly. That's what you have to say. Okay, that implies I'm moving to the next page. Yes, exactly. That implies the third piece means bigger piece. Yes, travels in a direction, making an angle of 135 degrees with the direction of first piece. So any mistake in my explanation and in my conclusion, Nana, here? Is there any mistake? No. Very good. Now come to the magnitude. What is the magnitude of this? Okay, means mod V3 bar. Mod is very simple. Ah, right. Magnitude is that all of root 2. Very good. Root 2. Very good. Root of perfect. Root of ax square plus ay square. Thank you. Thank you. Root of ax square plus ay square means that is root 2. Ah, yes. 1 plus 1 means minus 1 whole square plus minus 1 whole square. That equals to, right, good. Root 2 meters per second. So both the answers are over. Velocity of third piece, direction of third piece. Both are over. Okay. So is it clear, Nana? Any doubt in the middle or in the question? No doubt. Okay, very good. Yes, this is the magnitude and that is the direction. Yeah. Now you go little bit deep into the problem. One more. Will I give one more problem, Nana? Yes, but take care. It is little bit hard now. Okay, think wisely and try to say the answer. Good. Here he is saying that a body of mass, say some 12 kg, is projected obliquely, means related to motion in a plane chapter. Projected obliquely. What is this, Shravan? I did not understand. Okay, okay, right. Right, obliquely at an angle of 10 root 2 meters per second. Sorry, at an angle of 45 degrees with the horizontal, comma, with a velocity of 10 root 2 meters per second. Okay, this is the first information. Okay, better first you draw the diagram. What is happening there? So here I am taking the diagram. This is as usual horizontal and this is the vertical part, and a body is projected obliquely like this. Okay, but exactly at an angle of 45 degrees. So usually it tries to follow one path like this, tangentially here, and follows one path like this. Till then. Okay, you can continue that part here. Okay, no problem. Can I know? Right. Right, coming back to the problem. This initial velocity is given as 10 root 2 and angle of projection is 45 degrees. This is the information given here. And mass of the body is equals to 12 kg. Now what happened? Checking here. When it is at the maximum height, means when it reaches to the maximum height, my question is, still there also its velocity is 10 root 2 meters per second or some other? What is the velocity here at maximum height? Anyone remember? square by 2g. What you are saying, Nana Ishan? Ah, yes, Amog, you are right. Others, anyone remembered what is the velocity at maximum height? Lakshmi got it wrong, Nana. That is in case of a body projected vertically up. What you said? No, no, no. Even that is also wrong. What, Lakshmi Gayatri? You are also telling the wrong answers. What is this, Tali? Try to recollect. Uh, Except the required one, all other things you are recollecting. Manikanta, Debbals, 4G Entra, Badudai. Okay, 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 okay. So no one remembered. At maximum height, velocity will be horizontal, and that velocity is not zero, Manikanta. That is u cos theta in the projectile motion, Nana. I think all of you forgot this one. I believe, except Amok. Why? Because Amok only told the answer. That is u cos theta. Rest of the people, I think they forgot. Good sign. Okay, right? No problem. Try to recollect. So its velocity when it reaches to the maximum height, its velocity is u cos theta. Keep in mind. Okay. Means before happening something, its velocity is not zero, its velocity is u cos theta. That's what I'm saying. Right? When it is at maximum height, where its velocity is not equal to zero, the bomb or the body explodes into two pieces in the ratio 1 is to 2. 1 is to 2 means what are the two masses, Nana? Total mass is 12 kg. After explosion, the two masses are in the ratio 1 is to 2. What might be the two masses? Yeah, exactly, I'm correct. 2 plus 1, total 3 parts. 3 fours are. So 4 and 4 twos are 8. 4 is to 8. So M1 should be 4 kg, M2 should be 8 kg. Okay, means simultaneously I'm writing the data what is given there. And whereas before here u cos theta value is equals to, I'm writing here how much given, 10 root 2. Yes, exactly, that is 10 into cos 45, angle of projection 45 degrees. So that is equals to, I'm getting here cos 45 1 by root 2, that is equals to 10 meters per second u cos theta value. Okay. And what he is saying, when it is at maximum height, the body explodes into two pieces in the ratio of 1 is to 2. Okay. The lighter mass immediately, means instantly, immediately, falls freely. Are you able to hear my voice now? Yes, yes, yes. I think there is a problem here too, Mr. Aditya. Falls freely. Yeah, yeah, right. So here lighter mass immediately falls freely. Then the velocity or linear momentum, anyone. Ah, okay, no problem. The velocity of heavier mass is. This is the question. Okay. So here, what is the velocity of heavier mass? He is asking. So come to the here. If I give a chance, will anyone explain this problem? Anyone is ready to explain? If you say yes, I will give a chance to unmute your voice. Okay. No. Anyone here to say the method to solve this problem? Explosion means, again, I think you know the hint. You have to apply LCLF, law of conservation of linear momentum. You will get the idea. Why? Because almost all information here and hint I gave here to you know. One by one, I already opened the knots. No one is interested to say here. Okay, no problem. Right. Here, explodes at the highest point means during the explosion again, or better I write at the explosion. At the explosion. Again, my rule according to LCLM. This is suppose the instant, that is explosion. Before that instant, after that instant, I have to. Before, is it a single piece or two pieces before explosion? Am I right now? Yeah, one piece. And I think its velocity is also not equal to zero. Yeah, single, and its velocity is not equals to zero. Yes, its velocity is 10. That's why before explosion, P1 is not equal to zero like the previous problem. That is not at rest before exploding. Yeah. So here P1 is equals to, I write mass into velocity before the explosion. That I write mass is 12 kg into velocity, that is u cos theta. I found it as 10. Yeah, 10. Are you saying the final answer, Nana, Mr. Amol? I don't think it's so, Nana. We will check it. Here I am getting yes. What's your doubt? Yeah, okay, no problem. I think even that 120 by root 2, Akhil Kollapuri. We will check it. And better, since I don't know the direction after the explosion, I better believe the vectorial method by considering this as x-axis and this as y-axis. Since before the explosion it is moving along positive x-axis, I write it as I cap. So this is equals to 120 I cap. Do you have any doubt in this concept, Nana, here what I wrote before the explosion? Shall I move to after? No doubt. So, okay, right. So I'm moving to after the explosion. After the explosion, there are two pieces, Nana. Okay. Two pieces means after the explosion, I have to write two linear momentums. One, mass into velocity, that is 4 into 4 is the lighter mass, Nana. Go back to the question what he said. Lighter mass immediately falls freely. falls freely. Falls freely means what is the velocity here? 0, right? So 4 into 0, its velocity. That you will get 0. That's why nothing to write here, like I cap or j cap. No need to write anything here. Okay. Plus another piece. Another piece of mass, how much? H. That is mass into other piece velocity. I don't know. Let it be. Since there are only two masses, I write here P2 bar. Okay. Madikanta. Okay, right. Maybe none. I will check it. Now, first you understood this part, Nana? The linear momentum of two pieces in vector form. Or do you have any doubt here? Understood. Okay, right. Now using the law of conservation of, yes, law of conservation of linear momentum. Going back to here. So according to again LCLM, that is P1 bar before is equals to P2 bar after. P1 bar before is 120 I cap and P2 bar equals to 4 into 0, 0 plus 8 V2 bar. So here I'm not getting any negative sign, Nana. Straight away I say here 8 ones and 48 fives. I think V2 bar is equals to 15 I cap, Nana. Any mistake is there in my answer? No mistake. Yeah, exactly. So V2 bar is 15 I cap. I cap means along x axis, and there is no j cap, no k cap. That's why I say that implies magnitude of V2 bar is perfectly 15 along positive x axis. Okay. Positive x axis means look at the diagram, Nana. In the same direction before the explosion. Okay, why not? Sure. That only I told here. Like M1 V1 plus M2 V2 is equals to M into V. Same thing I use. I think no need to write to Mr. Manikanta. Perpendicular. Amo, I got here J cap or I cap. I cap only. I cap means in the same direction, na? Along x axis. Oh, the two pieces will go what you're saying. Okay, no problem. Right. Yeah, good. So after the explosion, the second piece here travels in the same direction of x-axis with a velocity. This is the direction of second piece, and I found its velocity is 50. Okay. Now you understood clearly, Nana? Why? Because I'm going to ask one interlinked question linked to this example. So, shall I ask confidently? Okay, right. So, you know the velocity of second piece here. That is 15 meters per second. Keep in mind. Now, I am going to ask M into V 0 intra Manikanta. Which MV is 0? You want to ask? Okay, you have a chance to unmute. From go to counting railways are metro. What, Manikanta? Net external force. Yeah, during the time of explosion, there is no external force. Oh, okay, no problem. That's what I explained. Force you told that net external force during the explosion it is zero. Okay, so I'm going to the question now. Next one, right? Uh, ni bondara ni bonda. What is that? Manikanta here before the explosion, its velocity is not zero. How can you say the momentum is zero? M into V. Right, coming to here. Yes. Anyone want to ask? Aishwarya. Okay, right. Then coming to here, the problem in the above example, going to the interlinked question. Okay, think perfectly here. Uh, Entora, what you are typing, Manikanta 330 and what you ask? Hey, unnecessary chatting here. Okay, right. In the above example, Nana, if you want to chat unnecessary things, you chat personally, Nana, not here in the group. Why? Because I'm also seeing your chat here. That's what I'm saying. If you want to ask those personal things, you can chat personally with your friends. I won't mind. So in the above example, here, okay, okay. In the above example, here what I'm asking, find the distance means horizontal distance traveled here traveled before hitting the ground. Number one, the level of the from the level of point of explosion, and number two, from the point of projection. Two questions are there here. Oh, Amor, 15 meters. It is very short. Okay, I will check it now. I will keep them in buffer and I will check. Uh, do you have the option to unmute your mic, Mr. Amok? When you resolve that problem, Nana? Okay, I think not 20 meters. Okay. Why? Because you are responding very quickly. That's why I am interested to know your to come to know your method. That's why I'm asking. Every time you are responding very quickly. But we have no opportunity here to hear your voice and your method of approach. Okay, no problem. So here it's our bad luck only, Mr. Abu. Uh, this is the body projected obliquely from here. Imra Manikanta, are you able to say? Lakshmi Gayatri, Satvika, Ratsuri, any others? Akhil, Aditya, iPhone, Angel, Ishan. Okay. No response from others. Uh, okay, first one you got some answer, Lakshmi Gayatri. Okay, no problem. Okay, okay, no problem. So anyone here? No, right. I think in the previous problem you got the velocity of second piece from the highest point. Okay. From the highest point, you got the velocity as 15 meters per second. Anna. This is the velocity of second piece. What you got at the highest point. With the help of the first previous question, I got here exactly along x-axis, and that is 15 meters per second. Okay. I will check, Nana. I think it is not correct, but even though I will check. From this point means I don't know in what way you solved this question. It is appeared to be projected from the top of a tower, like looks like. From this point, what I am saying. From that point, it is appeared to project from the top of a tower. Okay, appear to be projected from the top of a tower means that the top of the height of the tower is exactly maximum height of the originally projected one. So this maximum height is nothing but height of the tower. And from this level, first question is find the horizontal distance he is asking. From this level, the horizontal distance is nothing but the range in case of a body thrown horizontally from the top of a tower. I don't know whether you remember this concept or not. When a body, yes, that formula, Mr. Amogu, we have to use. Yes, you are right. That is from the top of a tower, if you know the velocity and the height of the tower, range is equals to, in case of horizontal projection, we have one formula in that chapter. U root 2h by g, where use the velocity here with what you are projecting. So in this case, u is equals to 15, and here I can substitute 15 into root of 2. H is the maximum height in the original case divided by g. Sir, how to find the maximum height in the original case, sir? Is it fine or no? Okay. Right. It is projected with a velocity of, I think, 2, and angle of projection is given as 45 degrees here in the original case. This is 10 root 2, and the angle of projection here 45. So in the original case, maximum height h is equals to your formula u square sine square theta by 2g. Okay. Here in this case, u is 10 root 2. Yeah, maybe. Yeah. If it is so, then it will be 5, I think. U square is yes, 10 root 2 whole square u square sine square theta sine square 45 by 2 into g is 10. 2 into 10 is 20. So this one by squaring you will get to 2 into 100, that is 200 by 20 into sine square 45 is 1 by root 2 whole square, that is 1 by 2. 20 tens and exactly what you said I accept. This is 5. Okay. So from this information you can continue here. Yeah, h is equals to 5 means I'm going to get going to substitute here 15. This is, yeah, 15. I write is equals to 15 root of 2. H is 5 by G is 10. 10, 10 cancel. I'm getting 15 meters. Someone put here the option 15. Amok, I think you went wrong. I don't know where you did the mistake. Yeah, I think Rachuri correct. Yeah. Manikanda, yeah, you are also correct. Right. 15. Yes, this is 15 meters. Range from here means first question answer is over now. From the level of here, the point of explosion. From this level, the horizontal distance traveled is 15 meters. Yes, Aditya, yes, you want to say? Right. Second question, he is asking from the point of projection. Okay. From the point of projection means from here to there. Suppose it is x, then x plus 15 is the answer. Will you accept or not? That is not the range of projected. Why? Because this one, where it lands, I don't know. After projecting, suppose it lands somewhere here. Till here, I am taking this is R. I calculated. Okay, till here. Here to there. Right? Is this Manikanta? Do you want to say something? This is the problem. If I give you a chance, you are simply unmuting and not telling any answer. Again, I am removing that option for you all. And then here, so this x up to the maximum height means that x is equals, I think you remembered in the original projection from the ground level, u cos theta into t. Remember, Nana, this formula? Or else exactly half of the range. Even that one also correct. Yes. And to the maximum height is this is the time of ascent. And here, sir, Amog is saying that instead of using this big equation, simple in the total range of original one, it is the half of the range. Why don't you take it as R by 2, sir? Even that is also correct. Yeah. I think I go with Amog Nana. Why? Because it is appear to be little bit easy. Okay. So with Amok's method, here x is equals to I am going with R by 2. R is u square by g sine 2 theta. All of you remember that is R by 2. Okay. That is this is time of s. R by 2 is 10 nano. Okay. I will check it then. That implies x is equals to I'm going to get there u square. Original projection u is how much here? 10 root 2. So u square 10 root 2 whole square sine 2 theta 2 into 45. This is 90, that becomes 1 by 2g is 10. 2 cancel. X is equals to I am going to get 10 nano. Yes, accepted. Yes, accepted. So total distance from the point of projection is x plus the new r. Okay, x plus r. R, how much you got there already? Here this is 15. Yeah, yeah, that is 10 plus 15. So all together, yeah, you can use u cos theta into ta also can be used. Yes, that implies answer for the second one is equals to 10 plus 15, that is equals to 25 meters. Yeah. Nana, Lakshmi Gayatri, have any doubt? You can check here. U cos theta into TA also you will get the same answer. U cos theta into TA is nothing but U sin theta by G. Yeah, yeah, yeah. That also you will get same 10. Very good. That method is also correct now. Okay. Why I went to this method, I always give the importance to the students' methods. That's why I went to the from what he said. This Amok said R by 2. That's why I gave the importance to the Amok's method. Okay, right. This is the story. So able to follow these questions first of all, and the methods how to solve. Are facing any issues here? Any trouble? Any hiccups? Did you face any hiccups here without water? No, no hiccups. Okay, right. So I think all of you understood. Okay, very good, Nana. All right, understood. Very good. Last but not least for today, related to this first law, again, applications of first law. Okay, coming to here, the last example. Okay, I think you can solve it. Why? Because it is not much hard. Just this is top of tower. Okay, whose height is given as say some 20 meters. This is 20 meters. What he gave here. This is 20 meters. And at the top, exactly a bomb is placed. Okay, exactly at the top of this one, and it explodes. Initially, it is at rest. A bomb is a bomb of mass. Better I write here. A bomb of mass 10 kg is at rest, comma, at the top of a wall, top of a wall of height 20 meters. Okay, so clearly mentioned P1 directly you can say that is equals to nana 0. Do you have any? Ah, right, correct. Directly P1 is equals to 0. This is before. Before I write, before the instant, after the instant. Before straight away I write here P1 is equals to mass into velocity, that is equals to 10 into 0, that equals to 0. Okay. Simultaneously, I am putting the information there in the solution. Okay. And then here you observe what happened after the explosion. Okay. Yes. It explodes into only two pieces. In case of two pieces, already yes, in yesterday's class I told whatever the two ratio of the masses of two, if a bomb at rest explodes, they travel perfectly in opposite directions. Remember this one, Nana, all of you. Yes, exactly. So here, suppose it explodes into two pieces like this. Okay, one piece and the second piece here exactly. It explodes into two pieces in the ratio of 1 is to 3. Okay, Nana? Find the ratio of horizontal distances, means ranges of two pieces. Okay, quickly we'll see anyone will put the answer or not. So will anybody say the two masses m1 and m2? 1 is to 3 means total parts of 4. Total mass is how much, Nana? 10. 10 by 4. 10 by 4 means 5 by 2, 2.5. So 0.5, other should be 2.5. 3s are 7.5. By taking the masses like this, are the two masses equal, are correct or wrong, Nana? Are the two masses correct or wrong? Yeah. Mr. Amo. Correct one. Mr. Amok, I think you are wrong this time. Yeah. Then, yeah, you are right, Mr. Amok. Sorry. You are right. You are right. So here the P2 I write, P2 is equals to, I write here what, first mass 2.5 into its velocity v1 plus second mass its velocity I write 7.5 into, I write that velocity as minus 2. Anyone remembered, anyone understood here why I put the negative sign? Yes, why? Because they travel. Already I know they travel in opposite directions. That's why. Since I know, I put the negative sign here. Yeah, why? Because they are in opposite direction. They travel in opposite direction. That implies I'm getting here using LCLM. Total linear momentum before is 0 is equals to 2.5 v1, and since I know the direction, I put the direction also minus 7.5 into v2, so that I'm getting v1 into 2.5 is equals to 7.5 into v2, so v1 is equals to, I got 3v2. Simply, or else v1 by v2 is equals to 3 is to 1. Okay, these are the two velocities, like smaller piece v1, bigger piece v2. Then I think nothing to explain. After exploding from the wall, they travel in opposite directions and follow the parabolic path like a body projected from the top of a tower. From the top of the tower, when a body is projected, already you know the range formula is u root 2 h by g. So he is asking the ratio of ranges. So range is equals to u root 2 h by g. Here both are started their motion from the same height. So h is constant, 2 is constant, g is constant. So straight away I write r is directly proportional to u. Did you follow this step, Nana? Since h is equals to constant, Or do you have any doubt? Followed or not? No doubt, right. Directly I write that implies R1 by R2 is equals to U1 by U2. Their velocities I took them as V1 and V2, not U1 and U2. That's why I write ratio of U1 by U2 as V1 by V2. Luckily, I got here that V1 by V2 ratio, that is 3 is to 1. Therefore, answer is R1 is to R2 is equals to V1 is to V2 is 3 is to 1. Okay, that's it. Okay, that is 3 is to 1. So, understood, Nana, here? Okay, this is the answer for the second question in the previous problem. And this is the answer for the first question in the previous example. And here, that's it. I already highlighted there. Okay, right, good. Yes, yes, yes. Yeah, yeah, that is also correct. That is also correct, Mr. Ramo. I accept. So I'm going to wind up, Nana. If you want the pages, you can take. Yes, this is the first page. Okay, second one. Okay, bye, Nana. Third one. Okay, and fourth one. Okay, that's all. Okay, shall I stop the class now? Bye, everyone, Nana. Thank you. Thank you. Bye, everyone.